Hello, today I'm going to be talking about finding the zeros of a function. I'm going to tell you a little bit about Newton's method, which is really cool. You may have heard of the bisection method. You might have done it maybe in a pre-calc class or something like that. And while you can find zeros this way, it can be a little bit slow. So they have the Newton's method, which is very, very fast. I'm going to show an example where you get very, very close approximation in just 4 iterations. This right here is the formula for Newton's method. P0 is an initial guess for your zero, f is your function, and P1, P2, etc. are all the points that you get for the zero after each successive iteration. This is the function we're going to do Newton's method on, and we're going to get that zero right there between -3 and -2. This is our first iteration. I used an initial guess of -2.5 because it was about in the middle, and what it actually did is it drew a tangent line at -2.5, and our next iteration point is going to be where the tangent line hits the x-axis, and this is kind of what's really neat about Newton's method. It keeps getting closer and closer if you keep doing this, taking the tangent line and getting the x-intercept. This is the second step. As we can see, we're getting a whole lot closer to what our actual zero is going to be. If we look at the next step, step 3, we got a little bit further away, but that doesn't really matter because the next iteration will get even closer. This is step 4, and as you can see, it's going to be the last one I do because we're right at the zero. If we zoom in really close, we'll probably see a little bit of a difference, and we could get even closer if we wanted, but I think this is good enough. So I hope you enjoyed learning about Newton's method. I know I enjoyed revisiting it. One thing that's pretty cool about Newton's method also is it's actually used in computer programs and calculators kind of behind the scenes. So I think it's neat to kind of know how computers and calculators get all these estimations for what we're looking for.